Good morning, dear students. Welcome again. Today, first of all, we will revise our reference electrode. You know very well, single electrode potential for any given couple you cannot be determined, but always potential difference can be determined. If potential difference can be determined with the help of electrode potential known as reference electrode. So today my first revision heading is reference electrode. The potential of a single electrode cannot be determined, but the potential difference between two electrodes can be accurately measured using reference electrode. And electrode is chosen as a reference with respect to which all other electrodes are types of electrode potential. That is, types of reference electrode potential, you can say. Reference electrode potential. The first one, primary electrode potential, and the second one, secondary electrode potential. A standard hydrogen electrode potential is said to be a primary electrode potential. So first we have to understand hydrogen as standard potential, or you can say a standard hydrogen electrode. Hydrogen standard potential, or you can say a standard hydrogen electrode. Pt S2 gas oblique S plus and 1. In this pattern of electrode potential, the concentration of hydrogen ion is considered to be 1 m, and temperature 25 degrees centigrade, that is room temperature, If pressure is given, P is equal to 180, or you can say 760 mm mercury per mole. Two pattern of reactions are possible. First one, reaction at cathode. You always know there is always reduction occur at cathode. So at cathode, we can write what? 2 electron gives S2. At anode, the reaction become reverse. That is S2 gives 2H plus 2 electron. This is gas and the concentration become 1m. Here also we can write concentration 1m, and this is said to be what? Gas. There is always oxidation occur at anode. So this pattern of reactions are possible in hydrogen standard potential, or you can say a standard hydrogen electrode. E naught S2 always considered to be what? 0. E naught S2 converted to H1 again said to be 0. The upper one called what? Reduction potential, and the lower one called what? Oxidation potential. So with the help of hydrogen electrode potential, we can determine the electrode potential of the other couples, and finally we find out the potential difference across it. Our next reference electrode is Callable Electrode. Callable Electrode is a type of secondary reference electrode. Callable Electrode, Ag2Cl. This is what? Secondary reference electrode. Representation PT oblique Hg Hg2Cl2 solid slash KCl aqueous. Here platinum electrode known as unreactive electrode is used. At cathode, half Hg2Cl2 solid except one electron converted into mercury plus Cl minus aqueous. This pattern of reaction become possible at cathode in Callable electrode. At anode, there is always oxidation occur. Hg plus Cl minus aqueous gives half Hg2Cl2 solid plus 1 electron. So this pattern of reaction become possible at anode, and this one become what? At cathode. This electron is said to be a secondary reference electrode. Okay. Next, we will revise our very important equation known as Nernst equation. With the help of Nernst equation, we can also find out the resulting electrode potential of the cell with the help of concentration. So this equation derive a relation between electrode potential and concentration of electrolytic solution, and finally find out the feasibility of the reaction. That is, our reaction become spontaneous or non-spontaneous in nature can also be understood with the help of Nernst equation. So we can write what? It gives a relationship between the electrode potential and ionic concentration of electrolytic solution. With the help of thermodynamics, we derive a relation between electrode potential of the cell and concentration of electrolytic solution. So from thermodynamics we can write from thermodynamics we can write what? Delta Z is equal to delta Z naught plus RT ln Q. In other form we can write delta G naught plus 2.303 RT log base 10 Q. Here base E converted into base 10 multiplied by 2.303. Delta G is known as what? Gives energy at non-standard state. Here gives energy at the standard state. R is equal to gas constant. T is equal to absolute temperature. Where Q is equal to reaction quotient. Where Q is equal to reaction quotient. That is ratio of concentration of product and concentration of reactant. Again we know that delta G is equal to minus N EF at a standard state E naught F. N number of electrons involved in each half cell. E is equal to electrode potential. F is equal to Faraday, that is 96500 Coulomb. So we can write delta G minus N EF minus N E naught F plus 2.303 RT log base 10 Q. Dividing by NF both the side. Dividing by minus NF both the sides. We get what? E is equal to E naught minus 2.303 RT divided by NF log base 10 Q. This is constant. R is also constant. At room temperature T is considered to be what? 25 degrees centigrade. F is also constant 96500 Coulomb. So at 25 degrees centigrade, we can write E is equal to E naught minus 0.059 divided by N log base 10 Q. Or you can write E is equal to E naught minus 0.059 by N log base 10 product concentration divided by reactant concentration. For cell reaction, we can write E cell is equal to E naught cell minus 0.059 by n log base 10 P by R. This equation is second, known as Nernst equation, where E naught cell is equal to E naught reduction plus E naught oxidation. The sum of oxidation potential and reduction potential gives the value of E naught cell. N is equal to number of electrons involved in each half cell. Here P and R, P means product, R means reactant, concentration of product by concentration of reactant. If all values are given, then we can find out the value of E cell and we can predict the spontaneity of the reaction. Similarly, we can write down the Nernst equation for single electrode potential. Nernst equation for electrode potential. Consider following: reduction reaction, that is Mn plus aqueous accept n number of electrons gives M solid. From Nernst equation we can write E, this is not complete cell, only reduction occur, we can write E, that is reduction couple, is equal to E naught reduction couple at the standard state minus 0.059 divided by n. Here we can write log base 10. The concentration of M solid is considered to be 1, and here we can write concentration of Mn plus aqueous. So if all terms are given, then we can find out reduction couple at non-standard state. One thing always remember, from Nernst equation we know that E cell is equal to E naught cell minus 0.059 by n log base 10 concentration of product by concentration of reactant. At the stage of an equilibrium, at the stage of an equilibrium, E cell is equal to 0 and concentration of product by concentration of reactant ratio is equal to what? Kc or Kp, known as equilibrium constant. So from this equation we can write what? E naught cell is equal to 0.0595 n log base 10 kc at equilibrium. That is E naught cell बराबर 0.059 by n log base 10 kc. This is the equation in which we can find out the equilibrium constant value with the help of E naught cell. Instead of 0.059, we can write what? E naught cell divided by 2.303 RT NF log base 10 kc. Because 2.303 R into T divided by F, the numerical value become what? 0.059. So we can write E naught cell into N into F is equal to what? 2.303 RT log base 10 kc. E naught cell into N into F is equal to what? Delta C. So we can write delta G naught, but sign become negative. So negative sign can be written in right side, minus 2.303 RT log base 10 kc. This is the relation between Gibbs free energy at a standard state and equilibrium constant. So if delta G naught is given, then again we can find out the value of equilibrium constant either in terms of concentration or pressure. Consider simple numerical based upon Nernst equation. Calculate E cell for the cell reaction Sn solid oblique Sn2 concentration is 1 m slash Pb2 10 to the power minus 3 m Pb solid. Given E naught Sn2 Sn is equal to minus 0.14 volt and E naught Pb2 oblique Pb is equal to minus 0.134. Our problem is what? We have to find out E cell value. For E cell, first we find out what? E naught cell. Here, two reduction couples are given. Higher reduction potential always reduce and lower reduction potential couple automatically oxidize. So E naught cell is equal to what? E naught reduction plus E naught oxidation. E naught reduction minus 0.13 plus E naught oxidation. Here the reduction couple is given. So the sign convention of oxidation potential is just reverse of the what? Reduction potential plus 0.14 volt. If we add, we get the value of what? Minus 0.08 volt. Why? because 0.14, 0.13, you get 0.01. So you get the value of what? So our inert cell value is 0.01 volt. This couple always reduce and this one oxidize. It become always true. So add cathode reduction occur. It accepts 2 electron, converted into what? PBS. And here oxidation occur at anode. Sn solid converted into Sn2 plus 1m plus 2 electron. So our equation become what? Pb2 plus 10 to the power minus 3m plus Sn solid gives Sn2 plus 1m and PBS. 2 electrons are involved in each half cell. According to Nernst equation, we know that E cell is equal to E naught cell minus 0.059 divided by n log base 10 product. Product means what? Sn2 plus divided by reactant Pb2 plus. The concentration of tin and lead is considered to be unity because existing solid phase. E cell is equal to E naught cell plus 0.01 minus 0.059 divided by 2 electrons involved in each half cell. Log base 10. Concentration of Sn2 1m and the concentration of Pb2 10 to the power minus 3. If we solve, we get the value of E cell, that is minus 0.08 volt. It means the negative sign indicate that our cell reaction is not feasible, that is move in backward direction. Our next heading is concentration cell. Concentration cells means same couple oxidize and reduce both, but the concentration of electrolyte become different. So in nutshell we can say when two similar electrolytes are taken with different concentration cell we can create. That is concentration cells. A concentration cells is a form of galvanic cell that has two equivalent half cells of the same material having difference only in concentration. In this type of cell, E naught cell is equal to what? 0. Because same couple is oxidized and reduce both. That's why E naught cell is equal to what? 0. Consider this example: silver solid oblique silver and suppose concentration is M slash Ag1, suppose concentration is here A2 and convert it to AgS. Always remember A2 is greater than A1. Then from Nernst equation we can write directly E cell, E naught cell is equal to 0 minus 0.059 number of electron involved in such case is equal to what? 1 log base 10 concentration of product, that is A1 by A2. This is a way to find out E cell for concentration cell. If A1 and A2 are given, then we can find out E cell easily. In concentration cell, instead of concentration, if pressure is given, then A1 by A2 ratio converted into in terms of pressure ratio. Our next heading is electrolytic conductance. Electrolytic conductance. You know very well, two type of things are present. First is known as what? Conductors, and second one insulators. Conductor means what? Good conductor of electricity. For example, NaCl aqueous, silver, copper, etc. Insulator means what? Bad conductor of electricity. For example, you consider wood, plastic, diamond, etc. In electrolytic conductors, the conducting power is due to movement of ions. Conductor are two types. First is known as metallic conductor, and second one electrolytic conductor. Electrolytic conductor due to movement of ions, whereas metallic conductors due to movement of what? Electron. Electrolytic conductance increases when temperature increases, whereas metallic conductor decreases when temperature increases. Electrolytic conductors are two types: stronger electrolytes and second one weaker electrolyte. Stronger electrolytes are very good conductor of electricity, whereas weaker electrolytes are good conductor of electricity but weaker compared to stronger electrolytes. Why? Because lesser ions become available in weaker electrolytes. In electrolytic conductance, first we know Ohm's law. What is the formula? V is equal to IR. V is equal to volt, I ampere current, R resistance. The unit of R is called what? Ohm. Ohm is a universal unit, but in SI unit, R can be written as what? kg meter square divided by second cube into ampere square. So always remember the SI unit of resistance is kg meter square divided by second power cube into ampere square. Second one, conductance is the reciprocal of what? Resistance. Unit ohm inverse or mho or Siemens. So such are the unit for what? Conductance. Third one, conductivity. Okay. The reciprocal of resistivity. This is known as resistivity. What is resistivity? We know that R is equal to rho into L by A. This rho is called what? Resistivity. Similarly, we can find out the unit of resistivity and conductivity. We can find out the unit of conductivity. K is equal to 1 by rho. It can be written as 1 by R into A into L. K is equal to 1 by R into L by A. This is known as conductivity. 1 by R, conductance, L by A, cell constant. The unit of K, we can write what? Ohm inverse, here centimeter square means centimeter inverse. Next one, molar conductivity. Molar is equal to K into 1000 divided by M, where M is equal to what? Molarity. Unit, we can write ohm inverse centimeter square per mole. When solution become diluted, molarity decreases, therefore molar conductance what increases. Similarly, we can define equivalent conductivity. K into 1000 divided by normality. Equivalent conductivity is similar to what? Molar conductivity. But we use N instead of M. N is called what? Normality. Unit, ohm inverse centimeter square per equivalent. Ohm inverse is also known as what? Siemens. The Siemens centimeter square per equivalent. When solution become diluted, again normality decreases and our equivalent conductivity what increases, whereas conductivity decreases after dilution. Why? Because volume of the solution increases when solution become diluted. This increases, it means K what decreases. Our next heading is Corral. You have already read. With the help of this law, we can determine the conducting power of any electrolytes with the help of ions at infinite dilution. So in terms of molar conductivity, Corral's law can be written as what? Lambda plus infinity plus lambda minus infinity. V1, V2, where V1 and V2 are called what? Number of atoms of cation and anion. So when molar conductivity of cation and anion are given, the sum of these two is said to be what? Molar conductivity of electrolyte at infinite dilution. This law is known as what? Corral's law. But in terms of equivalent, this plus and this minus. This is said to be what? Molar. Divided by 1 by n plus 1 by n minus. So when molar conductivity divided by magnitude of the charge of cation, and similarly for anion, such sum again said to be what? Equivalent conductivity at infinite dilution of an electrolyte. With the help of this law, we can calculate what? Alpha, degree of dissociation. Molar conductivity at given concentration, molar conductivity at infinite dilution. Such ratio is called what? Degree of dissociation. So the degree of dissociation of weaker electrolytes can be determined with the help of Corral's law. Okay, so our topic is completed. Best of luck for your coming first term examination. Thank you.